Today in class we talked about sigma notation, and we learned that sigma notation is a Greek letter, this is your sigma, and it's used to express a series or its sum in an abbreviated form. And we're going to keep it really simple on this unit. So if you see something like this, this is your sigma, and the number at the bottom tells you where to start your series, and the number at the top tells you where to end your series. And when you read this as the sum of k squared for values of k from 1 to 100. So if I asked you to expand something like this, it would look like this here. We plug in 1 for k. 1 squared, what comes after 1? 2, 3, 4, and so on, all the way until we get to 100. So if I asked you to expand this sigma notation, it would look like that. And then we'd go simplify. 1 squared is 1, 2 squared is 4, 3 squared is 9, dot, 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 all the way to 100 squared. So all we do after this is we're going to practice a few. So on example 1 right here, it says, write the given series in expanded form. And it says on this one, we're going to write a series that k starts at 1. This is where it starts. And it's going to end at 4. And we're just going to plug into this equation. So 5 times 1 is a series, plus 5 times after 1 comes 2, plus 5 after 2 comes 3, plus 5 after 3 comes 4. And we're not going to go any further than 4 because it says that my series is going to end at 4. Then I'm going to go simplify this. And I'm done. I expanded the series that was written in sigma notation. If they asked you to evaluate, then you'd go add all these up. So if they asked me to evaluate, 5 plus 10 is 15, plus 15 more is 30, plus 20 more is 50. Example 2. They want me again to expand the series as k starts at 1 and goes to n. Well, n is not a given number. It means it can be anything I pick. And I'm going to pick right now, n is going to be infinity. So we're going to have 3 to the very first number I'm going to plug in for k is 1. Then I'm going to have 3 to, after 1 comes 2. I'm going to have 3 to the 3 plus 1, plus dot, 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 3 to the n plus 1. And again, n is going to go on to infinity. So we're going to leave it like that. I'm going to go ahead and simplify. 1 plus 1 is 2. 2 plus 1 is 3, 3 plus 1 is 4, dot, 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 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81, dot, 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 3 to the n plus 1. And that's it. We expanded it. On example 3, it's very, very similar. The only thing different is we're not starting at 1. This time we're starting at 3. So I'm going to go plug in 3 where that k is. We're going to have 3 squared plus 4 squared plus 5 squared plus 6 squared. And then we're going to stop because it says to stop at 6. So 9 plus 16 plus 25 plus 36. So I expanded it. And if they ask you to add them, you can add them all up. All right, so now what we're going to do is we're going to go backwards. I'm going to give you the series, and I'm going to show you how to get the sigma. So my strategy when I go backwards is I'm looking for what's changing. Whatever's changing, I'm going to say is going to be my k. So I've got a 2, a 3, a 4, and an 8. So these bases are changing, and every one of these bases is being raised to the power of 4. So one way to write this, and there's many, but one way would be to say that k starts at 2, and it goes to 8, and we're going to have k to the 4th power. Now there are other ways. Somebody in one of my other classes asked if they could start it at 1 and do k plus 1. And I was like, sure, not a problem. As long as if when you go plug in, you get these same answers, then it's correct. Example 5. I'm giving you this series 4 plus 8 plus 12 plus 16 plus 20. So when we were doing this one, most of my classes were like, oh, you're adding 4 over and over and over. And I was like, yes. And then what I said is if you're going to add 4 over and over and over and over, it's the same as multiplication. Writing 4 plus 1, 4 plus 4 plus 4 plus 4 plus 4 plus 4 is just like saying 4 times 6 or 4 times 5. So I'm going to go rewrite all of these as multiplication. 4 times what is 4? 4 times 1. 4 times what is 8? 4 times 2. And then we get 4 times 3, 4 times 4, and 4 times 5. And again, whatever's changing is my k. So every time this number in the parentheses is changing and this number outside is staying the same. So I'm going to write my sigma. My first k was 1, and my last k, the last number in the parentheses, was 5. And every one of these k's, the 1, the 2, the 3, the 4, and the 5, were multiplied by 4. So when you have repeated addition, I was adding 4 every time. When you have repeated addition, we're going to write them as multiplication. Okay. On example 6, we're going from 1/3 to 1/9 to 1 over 27. This time we're not adding the same number, we're multiplying. And we're multiplying by 1/3. 1/3 times 1, and then I said 1/3 times 1/3, 1/3 times 1/9. When you have repeated multiplication, we're going to write those as powers. So 1/3 to the first power is 1/3. 1/3 to the second power is 1/9. 1/3 to the third power is 1 over 27 plus ... So again, it's the exponents that's changing. So my k is going to be an exponent. My base is staying the same. My first k value was 1, and because it goes ... I'm going to go off to infinity. All right, so let's recap one more time. If you have repeated addition, I added 4, added 4, added 4, added 4 to get the next number, then we're going to write it as multiplication. If you have repeated multiplication, 1/3 times 1/3, 1/9 times 1/3, if you have repeated multiplication, we're going to write it as a power. So on this one, we go from 1 to -1/2 to +1/4 to -1/8 to +1/16 to -1/32. So what am I doing to get from 1 to -1/2 to 1/4 to -1/8 to +1/16 to -1/32? We're multiplying by -1/2. So since it's repeated multiplication, we're going to write it as a power. All right, my first number has to be 1. So -1/2 to the what power would give me a +1 to the 0. And then -1/2 to the first power would give me -1/2. And -1/2 to the second power would give me 1/4, and so on and so on and so on. So on this sigma, I'm going to start my k at 0, and it's going to go all the way until I get to 32. So 0 power, first power, second power, third power, fourth power, fifth power. And we're going to have -1/2 to the k. So your homework tonight is to do worksheet 13-6, and I omitted 3 problems, 19, 27, and 33. Don't forget that your late work was due today, and if you want to turn in your assessment for extra points, I need it by this Wednesday. Hope this helped.